Hi everyone and welcome back to the channel. If you're into SAP and Python, you are in the right place. Today we are doing something a little different. Before we write a single line of code for our big project, the AI-powered demand forecasting app, we are going to do what architects do before they lay a single brick. We are going to look at the blueprint. We are going to tell a story. It's the story of how a simple question from a user can trigger a complex, lightning-fast journey through our SAP database to deliver a smart, AI-powered answer. Understanding this story, the data flow is the key to building great enterprise application. So grab a coffee, get comfortable, and let's dive in. All right, let's meet our user, Klaus. Is a warehouse manager, and he's got a thought job every month. He has to figure out how many of each product to order. Let's take one product, for example, banana. We can choose our banana, select banana. And this banana material number mat 001. We can say it material 1. They are very popular. If Klaus ordered too few, the customers are unhappy. If he orders too many, the bananas go bad and the company loses money. In the past, Klaus would look at some old spreadsheet and just guess. It was stressful and his guesses weren't always right. But now Klaus has a plan for a new AI forecasting app. Since we don't have the app built yet, we're going to explain the process on our fingers. Using the database blueprint we designed, we are going to pretend we are the application and follow the data. Here is a simple business question Klaus has. How many bananas? Mat 1, Mat 1 will I need soon for main warehouse the E01. The entire goal of our application is to use the data in all these different tables to produce a simple, clear answer for him. The final result should look something like this. Forecast for banana, material 1, predicted demand next 30 days. We see this is 85,000 pieces current stock on hand, 100,000 pieces, and status okay. This was our forecasting should look like. For Cloud, this is the perfect result. He gets a simple, actionable answer to his complex question. He knows he doesn't need to order bananas today. But for us, the developers, the journey is just beginning. How do we get from a simple question to that magic number 85,000? How do all our tables work together to make this happen? The answer lies in our data model. So before we follow the journey of a single sale, let's quickly meet our cast of characters, the main tables in our database. A good question to ask is, why do we need all these different tables? Let's answer that right now. Okay, and now we see our table, our first table, name Zmara. Zmara. Yeah, let's see. Zmara table. Their product list. We can say that this is their product list. This is our master catalog. Its job is to ensure every product we sell is a real, unique item. It's the single source of truth for all of products. Because if in these tables our product exists, we can guarantee that it exists for our requests and so on. Next table, the marked, the descriptions. This table just gives our products a name in different languages. We need it so we can show banana to an English, user and banana to German user, or as you see, it can be juice in English or Saft in German, and that's why we have this table. That's all. The MARD, the stock shelves. This tells us exactly how much of a product we have. Wait a minute. The MARD. How much of products we have in a specific physical location, like Shell A in warehouse Frankfurt, for example. Okay. Yeah. We need this to know our current stock level and levels. Next table, ZMARM. ZMARM, this table, the rule book. We can name this so. This is our conversation calculator. Its only job is to teach the system the math. Like we, with help of this table, we can get to know, for example, one package, it's 12 pieces, and one box, it's 48 pieces. It's like we needed this to automate calculations and avoid human errors to calculate our pieces. ZVBRP, the sales log. This is the detailed log. This is the detailed log of every single item ever sold. This is the most important table for our AI because it contains our demand history or our history. Next tables, ZV book, then ZVBRK, the invoice summary book, VBRK. These two work together. The VBook is the fast ID card, we can say, that tell us if an invoice is complete, and the VBRK is the full file with the summary or info like the tail, like the date and total value. We need them to make sure we only use real completed sales for our forecast. Why we have this table? Because first, in order to don't make a request in VBRK table, because this table consists and has a huge amount of information. First, we need to check if our status, if our records for our bills exist, and we can check status our orders, and then if it exists, we can make our request to VBRK, because it costed too much for our system if we direct make this request to this table. Yeah. Now that we have made the cast and we understand why each table has a specific job, let's see them in action. Let's follow the data flow. Our diagram. Let's quickly review how our program will use these tables. You'll see I have shown relationship like one to many, many to one, but you might have also noticed that in the data I've highlighted foreign key for mandate field, for field our client. But in real subtables, this field doesn't specified. This is to show implicit connection. In SAP, almost every table has mandate. This is our client as at the very first field in its primary key. This is the client field. It keeps the data for different companies or departments completely separate. When we say a program search for a material number, for example, search for material number or our our order number, behind the scene, we always searching for the mandate number, our client, and number. This is most fundamental rule in SAP. It guarantees we are always working with the data from the correct client. Since Klaus logged into client 100, imagine that all our lookups will implicitly be for that client 100. Okay, you need to just remember it. Okay, with that in mind, let's follow the journey step by step. First, our Fiori app or any client app send message to our Python API. First, our Fiori app or any client app sends message to our Python API on the SAP Business Technology platform. It's a simple message. Klaus wants a forecast for material 1 in plant DE01. Our Python apps knows that to predict the future, it must understand the past. It needs the sales history, so it calls our OData service in SAP and asks, give me all the completed sales for material number 1. Okay, let's come back for our tables. Our Bobcode wakes up, it knows that Klaus is logged into client 100. Its first step to find all the historical sales for material 1. It looks in the VBRP table and find all VBRP table and finds all the rows where material number is 1, material number 1. In client 100. We can remember it. Okay. It see that this material was sold on several different invoices. For example, in our cases, these invoices 19,001 and 90,002. Now, for each of these sales items, the program does a quality check. It takes the invoice number we bill from the current row. This is where one of our most important relationship comes into many-to-one relationship from VBPR to the book table, because as you see, we have the book table, we have VBRP table many to one the book, because exactly we can have, as you see, for example, these two records. It's many because we have two records with the same VBELN order number, but in our webbook table we have only one records. We can't have multiple records because we have here relationship one to many. Many sales item can belong to one single invoice. The program uses VBELN to find the status, but just like we discussed before, this connection is also implicitly using the client. It's always implicitly using the client. The real technical foreign key is a combination mandate plus VBELN. That's why I highlighted it in another color. This guarantees that the program looks up the status for correct invoice in the correct clients. It finds that one ID card, we can say ID card check, record in that webbook and checks if the status is complete. And we can see exactly that letter C, that means that status is complete. This is a professional check to make sure we don't use the data from canceled or unsatisfied sales. If the status is good, it can then get more details from the full file table VBRK. Because in real SAP projects and real SAP system, our VBRK table contains a lot of amount of information, and that's why our table webbook created for check. If we can guarantee that we see status completed, then we can request for our data to VBRK table, because it makes sense that our system can spend this resource for request. Okay. And this is where one-to-one relationship between VBUK and VBRK it's important. We also have VBRK one-to-one webbook, because as you see, we have 90,001 and 90,001 only one-to-one, because these records could be doubled. Okay, it's important. The purpose of VBRK is hold the summary information for the entire invoice. This holds summary information for entire invoice. And we can say that implicitly behind the scene, we can see that we can calculate for our VBEL 90,001 some amount of money, and you see this sum. And as I said before, we hold in this table VBRK information for the entire invoice, like total value, netware, and the invoice data. That the summary information is calculated implicitly behind the scene by adding up all the item values from VBRP that shares the same VBEL as I showed before. The most important clue it gets from VBRP is field FKIMG, the final quantity of items sold. The final quantity of items sold. Okay. Yeah, because this information really important for our IE, that our IE needs. Next, the Python apps ask another question. Okay, what the stock level for material 1 right now, but only in plant DE01. Our above code runs again. This time it goes to the MARD table. We goes in our Smart table. It's important to remember that Smart hold the stock details for many location. It could be DE2, DE1, many location. But the single source of truth for the product itself is Mara table, and we can check, and that's why we have relationship Mart table to Mara table, many to one, because it's a source of truth. If our goods or our products exist in Mara table, we can guarantee that it exists in our subsystem, and we can make requests and calculate our quantity or whatever we want. Our program uses this link by searching the Mart for all rows where mandate 100, material number 1, and works the E1. And as you see, as I said, material number, and okay, the E1. Okay. It then adds up the stock from all the different storage, because as you see, this is lager ort, this is storage. This is storage because this is number our shell in our specific warehouse. And get out, and this sends back one single number to us. Now our Python app has everything it needs. It has the clean sales history to our machine learning model. The model analyzes the patterns and predict the future demand 850. But 850 is just a number. We need to make it friendly for Klaus. Our Python app makes one last quick trip to SAP. This time it asks, what is the name and official unit for material number 1? Because until then we only know that it is material number 1. But Klaus knows that it is banana, but our system doesn't know yet. This above program looks the mact to find name banana, and that's why we have relationship between mact and Mara, many to one, because we have our single table and source of true. And above program looks in SMART table to find banana, and as you see we have banana here, yeah, for mandate 100 and language E. Then looks in Smara to find base unit, and exactly we see that base unit is PC for mandate 100. This is the lookups relationship we talk about. The program uses material number as a key to find information in another table. It's like using a user SD to find a username in a different system. In the Smara table, our data in field mines keeps the minimal possible unit of measure in our system. And the Python apps now assembles the complete package, the forecast, the stock, the name, the unit, and sends it all back to the Fiori app, which display the final simple screens that Klaus sees. Okay, and there you have it, that entire journey across platform from ABAP to Python through half a dozen tables. Happens in just a couple of seconds. It's not magic, it's just good design, because we took the time to build our tables correctly with the right relationship and the right fields. The whole process works smoothly and reliably. The data models is the strong foundation that makes the cool AI future possible. I hope this story helped you see the big picture of how all these pieces connect. In our next video, we are going to roll up our sleeves and actually get into subsystem to start building these tables from scratch. And of course, we talk about each field in more detail then. It's going to be a lot of fun. So fun as SAP can provide us. Thanks for watching. Be sure to like and subscribe, and I'll see you in the next one. Bye.